Okay, here we go. We are going to find the slope of the line that passes through the two given points. And to do that, we're going to use our formula for slope, which is m equals rise divided by run. So we're going to find the rise, we're going to find the run, take the quotient of those. That could be written as delta y divided by delta x. It could also be written as y1 minus y2 divided by x1 minus x2. Now to achieve this, we also have the option of plotting points. In this case, I need a lot of space to plot points, and drawing the line. But maybe I'll do that anyway. Let's see if I can get that done here. So I need just like a little bit more space to do that. Okay. The problem is I'm going to lose all my other space, but oh well. Okay, so here's there's 2, 1, 2, 3, 4. So here I get the point 2, 4, and then I can do the other one, 4, 10. That's up here. And I can draw the line through these points. I mean, I don't think this is what I had meant or the book had meant when you're doing this problem is to plot points and find the slope by looking at that, but possibly. Actually, I shouldn't speak, so certain with such certainty of what the author might have thought. But what you can do is, once you get that done, is you can draw a little triangle here. Now, yeah, okay, I'll go ahead and do that. I don't really actually have to make it this big of a triangle. I could also make a smaller triangle here and use, from the graph, I can see there's another point that wasn't given, but I can see that there's another one, which is apparently 3, 7. Okay, so I could use those there. But anyway, once I get that drawn, I can see what's going on. Okay, but what's going to happen now that I've drawn that is I can start seeing what's going on with this rise or run business. See, what happens is I take the difference in the y values. Okay, and that's going to give us 10 minus 4, which, we can do in our head, that's 6. Sometimes it's a little tricky what's going on. By the way, let's get rid of this point here. Okay, so that's the rise. That's y1 minus y2. Now, which one I decide to be y1 and which one y2, it doesn't matter. I could do actually 4 minus 10. I could do that. And then we look at the x coordinates there of those 2 points, and that gives the run, and I do 4 minus 2. Now, okay, so let me just continue on this. So that's going to be 6 over 2, which we see is 3. But we could write that m equals 4 minus 10 over 2 minus 4. So it's possible, and just fine actually, to reverse those. We can reverse those because we see that we get, when I flip the order of the difference when I'm subtracting, it changes, say from 10 minus 4, it changes from 6 to negative 6 by flipping that order of subtraction. But if I'm consistent and do that with a denominator, I'll get the same number. So finally, I wrote it down a lot for this problem, but that's what I get. And let's look at what's going on in this picture. The rise is 6 and the run is 2. So just from the graph, you can see that we have a slope of 3. The slope is a ratio between the change in y and the change in x. So it's change in y divided by the change of x. Okay, so let's see what is that problem. This is from section 2.1, Openstax Precalculus. It's problem number 25.